Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. ଏଥିରେ ମୁଁ ଅଲରେଡ଼ି ପ୍ଲସ୍ ଟୁ ସେକେଣ୍ଡ ଇୟର ସିଲାବସ୍ କମ୍ପ୍ଲିଟ୍ କରିସାରିଛି। ଏବେ ମୁଁ ପ୍ଲସ୍ ଥ୍ରୀ CBCS ଫିଜିକ୍ସ ଅନର୍ସ GE ଆଉ MSc ଫିଜିକ୍ସ ଅନଲାଇନ୍ କ୍ଲାसेसର ଭିଡ଼ିଓଜ୍ ଅପଲୋଡ଼ କରୁଛି। ଯଦି ଭଲ ଲାଗିଲା ତାହେଲେ ଭିଡ଼ିଓଜକୁ ଲାଇକ୍ କରିଦେବ ଆଉ ଚ୍ୟାନେଲକୁ ସବସ୍କ୍ରାଇବ୍ କରିଦେବ। ୟୁ କ୍ୟାନ୍ ସେୟାର ଇଟ୍ ୱିଥ୍ ୟୋର ଫ୍ରେଣ୍ଡସ୍ ଅଲସୋ, ଇଟ୍ସ କମ୍ପ୍ଲିଟଲି ଫ୍ରି ଅଫ୍ କଷ୍ଟ। लेटेस्ट वीडियो नोटिफिकेशन ପାଇଁ बेल आइकन को एठी ऑल रे सेट कर दबो। तापर वीडियोज रो क्लैरिटी बढ़ावा ପାଇଁ गो टू सेटिंग्स, क्वालिटी, एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन। सबू वीडियोज ପାଇଁ पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स। तापर मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो। ओके, थैंक यू। हेलो स्टूडेंट्स, आज टॉपिक रे हमें फर्मी-डिराक स्टैटिस्टिक्स एंड इट्स डिस्ट्रीब्यूशन फंक्शन ए विषय पढ़ा। देखो, फर्मी-डिराक स्टैटिस्टिक्स कहले हमें ऑलरेडी जानिला जे इट इज एक्चुअली अ क्वांटम स्टैटिस्टिक्स वेयर द डिस्ट्रीब्यूशन ऑफ आइडेंटिकल indistinguishable particles, okay, they are, and they obey the Pauli exclusion principle, according to which no two particles can occupy the same quantum state or same energy state, okay, and they obey this Fermi-Dirac statistics and hence called fermions. Okay, so fermions are the particles which are indistinguishable obeying the Pauli exclusion principle. Okay, so as I said, no two particles can occupy the same state or quantum state at the same time. Okay, and examples are like electron, proton, neutron, neutrino, muons. Okay, now the collection of non-interacting fermions is called a fermion gas. So Pauli exclusion principle is only applicable to fermions, and the particles which form the asymmetric quantum state are having half integer spin. Okay, and here the spin is an intrinsic angular momentum of that elementary particle. So all particles have either integer spin or half integer spin which are having the values in the units of Planck's constant divided by 2 pi, that is h by 2 pi or h cross. So one possible way of visualizing the spin of fermion is that they have to be rotated by two full rotations in order to return them to their initial state. So let us consider a system having n indistinguishable particles which obey the Fermi-Dirac statistics. Now we have to determine the energy or momentum distribution of these particles in the most probable or equilibrium state. Okay, so for this purpose let us divide the available volume in the phase space into a large number of, let us say, k compartments. Okay, and each compartment represent a small interval of energy or momentum, and each of these compartment is further divided into elementary cell of size h cube, h equal to Planck's constant. So macro state जदि आमे देखिबा of n1 n2 dot 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 up to nk, where ni is a middle number and its total energy of these indistinguishable particles, okay, this will be given. Now total ebe आसीगला जदि n equal to n1 plus n2 plus सब plus कर देला up to nk हेगला total टा. Now to derive the Fermi-Dirac distribution law, we consider that the number of elementary cells in the ith compartment is gi. Okay, ता सहित we make the following conditions. कौन condition? The particles are indistinguishable so that there is no distinction, आमे जानी परिबा नहीं को particle कोटा. Okay, there is no distinction between various ways in which ni particles are chosen, okay, or they are arranged. Now the particles obey Pauli exclusion principle, according to which there can be either no particle or just one particle in a given cell. Okay, hence number of cells must be more than number of particles. Okay, because या तो बिल्कुल भी particle रहिबनी किंबा at least गोटे ही particle रहिबो, निहाती भाबरे cell संख्या हेबे number of particle रु बेसी ही हेबो. So gi is greater than ni. Now out of a total gi cells, ni are filled, okay, and remaining gi minus ni will remain vacant. Okay, suppose gi cell for example ରହୁଛି 100ଟା, ଆମ ହାତରେ ପାର୍ଟିକଲ ଅଛି ସପୋଜ 80ଟା, ଗୋଟେ ସେଲରେ କେବଳ ଗୋଟେ ହିଁ ପାର୍ଟିକଲ ରହିପାରିବ, ତାହେଲେ 80ଟା ସେଲ୍ ଫିଲ୍ଅପ୍ ହେଇଗଲା, ବାକି 20ଟା ଭ୍ୟାକେଣ୍ଟ ହିଁ ରହିବ। ସୋ ଦିସ୍ ଇଜ୍ 100 minus 8, 100 minus 80 which is 20. Okay, so gi minus ni cells will remain vacant, and now the gi cells can be arranged between themselves in gi factorial ways. Out of these ni factorial এই permutation যদি আমি দেখিবা among যেহেতু এটা indistinguishable particle রହୁଛି, this will be meaningless as they do not give any different arrangements. Okay, so याको हमको काटिबाको पड़िबो। Similarly gi minus ni जोटा vacant रहेला permutation between the vacant cells will also be meaningless. So total number of permutation hela केते gi factorial, total number meaningless hela केते दुईटार product ni factorial and gi minus ni factorial, তাহলে total number of permutation equal to number of meaningful into number of meaningless permutation. Okay, and there the number of different ways of arranging ni fermions among gi cells will be how much? gi factorial at a total divided by जो product thila meaningless. Okay, so hence the total number of meaningful arrangements or thermodynamic probability जोटा कि microstate होउची, okay, of this macrostate, that is ni n2 up to dot 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 n1 n2 up to dot 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 nk of the system is therefore w equal to multiplication from I equal to 1 to k of this quantity gi factorial divided by gi minus ni factorial into ni factorial. So as I said, this is the multiplication standing for the product of all the terms with various values of I ranging from 1 to k. Now taking the natural logarithm, we get ln w equal to, now this multiplication becomes a summation. Okay, ए हिसाब रे न्यूमरेटर और डिनोमिनेटर डिस्ट्रीब्यूट हो गला, डिनोमिनेटर आगे माइनस रहिबो. Now we can apply the Stillings formula because ni is very greater than 1. ताले h पर Stillings formula ln ni factorial equal to ni ln ni minus ni. So ए हिसाब रे तीनटा टर्म आमे पाई जिबा. याकू फर्दर टिके सॉल्व करिबा. Now to find the state of maximum thermodynamic probability or equilibrium state, we differentiate both sides by keeping gi constant and ni as the variable. So d of ln w एबे differentiate कर देले देखो, याकू आमे एबे product rule हिसाब रे लिखि देला. ओके, एठी फर्स्ट ln रो आछि differentiation, तापरे आछि तमरो dni ln gi minus ni. ओके, ni को आमे वेरिएबल नौछु मने रखो. तापरे नेक्स्ट टर्म गुडा भी सही हिसाब रे लिखि पारिबा आमे. ओके, मने रखो gi को जेतु कांस्टेंट रखुछु, ताले gi ln gi याकू डिफरेंशिएट करले एटा 0 ही दबो, राइट. सो एबे याकू आमे सॉल्व करि जबा जदी dni कॉमन नै गला बाहर को. ओके, नाउ फॉर ए सिस्टम to be in equilibrium, the thermodynamic probability w and subsequently in w will be maximum, so that its differentiation of the ln will be equal to 0. So this quantity in the RHS must be equal to 0. Now we also know that the system must satisfy two auxiliary conditions. कौन सेटा? Number 1, the conservation of total number of particles. So the value of n will be equal to constant. That means dn must be equal to 0, summation over dni, right? तापरे second condition कहूची conservation of total energy of the system, that is u equal to constant. So du which is summation over ui dni equal to 0. So एबे इक्वेशन 32 रे ऊपर जो हम फर्स्ट इक्वेशन रे पाई थिला, आमे मल्टीप्लाई करिवा with minus alpha and minus beta, and एबे ऐड करिवा with equation 30, then we get this much. Okay, देखो इक्वेशन 32 माने ए इक्वेशन टा. ओके, मल्टीप्लाई करिकी एबे हमको कोन करिवार अछि ना ऐड करिवार अछि. ओके, सिमिलरली 33 रे आमे माइनस बीटा मल्टीप्लाई करबा और ऐड करबा ओके ताले ये इक्वेशन जो आमे पाइला हियर since various terms for different values of I are independent of each other so the quantity within the brackets in the above equation must vanish for all values of I तेणु करी ए ब्रैकेट रे थिबा क्वांटिटी को ही हमको जीरो सहित इक्वेट करबा को पड़िबो राइट सो हमरो नेक्स्ट टास्क हला टू कैलकुलेट द वैल्यू ऑफ ni ln को आर पट को नहीं गले एक्सपोनेंशियल ही जाए सो फाइनली ni your value by putting beta equal to 1 by kt we get this much okay it is equal to gi divided by e to the power alpha e to the power ui by kt plus 1. So this equation what we have got is called as the Fermi-Dirac distribution law and the value of the constant alpha can be calculated as per the condition of a particular system where this distribution is to be applied. Now since denominator যদি লক্ষ্য করিব in the above expression is greater than or equal to 1 so for the Fermi-Dirac or FD system the occupation index মানে ni by gi এই ভ্যালুটা is always less than or equal to 1 irrespective of the value of alpha ui and t so special case যদি আমি নোট করুছু ui যদি very very greater than kt হଉଛି তাহলে this occupation index ni by gi will approach towards the classical that is Maxwell-Boltzmann statistics okay now up to this I have taken from one book now you see this I have taken for the Fermi-Dirac distribution law and the Fermi-Dirac statistics from another book okay so ei boy re ya bisare bi also lekhichi detail way re okay you can read from this book also right finally देखो same way रे यार expression distribution function ये काढुची and I रो so you read from both the books and make your note accordingly.
Thank you.